In this video, we're going to explore the next of our special parallelograms called the rhombus. So first of all, what makes a rhombus a rhombus? A rhombus is a parallelogram that happens to have four congruent sides. So in other words, if you want to join the rhombus family and be a member, the only requirement you need to fulfill is you need to have four congruent sides. And when you have four congruent sides, you automatically get in and get to belong to the rhombus club. Now, because a rhombus does happen to be a parallelogram, it's going to have all of the special properties of a parallelogram. But in addition to those, the rhombus has a little something extra going for it. The first something extra that the rhombus has that an ordinary parallelogram doesn't always have is that his diagonals are always perpendicular. And the right angles formed by perpendicular lines bring some new and exciting things that we can apply to the rhombus. The other thing that the rhombus has going for it, that not every parallelogram does, is that it just so happens that the diagonals bisect pairs of opposite angles. So in other words, the diagonal is a bisector for these opposite angles. Now that said, because we know that the opposite angles of every parallelogram are congruent, we know that we're starting with congruent angles, and therefore we're going to be ending with congruent halves when we bisect them. All right, so let's go ahead and see how we can use these properties to go ahead and solve some problems. Number one, it says in simplest radical form, find the perimeter of a rhombus whose diagonals have length 12 and 18. So because they don't give me a picture here, the very first thing I'm going to do is draw a picture. And since this question is dealing with the diagonals, I'm going to go ahead and in my picture draw the diagonals. I know that in a rhombus, the diagonals have to be perpendicular. So I know that all four of those angles where the diagonals meet are right angles. The length of one diagonal is 12 inches, and I'm going to break that down so that each piece is 6 and 6. The length of the other diagonal, 18 inches, and I'm going to break that down so each piece is 9 and 9. And really what we're trying to do is we're trying to find the perimeter of this rhombus, and in order to find its perimeter, we're going to need to add together all of its sides. So what I really need to do is I need to find a side length. I'm going to call this side length x. From this point, I'm going to go ahead and I'm going to look at the triangle, the right triangle that I just highlighted in yellow. So if I look at that right triangle, what I've got is I've got a triangle where I know that one of the legs has length 6, the other leg has length 9, and I'm trying to find the hypotenuse, x. So this question is set up perfectly to use the Pythagorean theorem. Just be careful, and when you substitute into the Pythagorean theorem, make sure that your C is the side opposite the right angle. So in other words here, I've got 6 squared plus 9 squared equals x squared. And now I'm simply going to grab my calculator, and into my calculator I'm going to type that 6 squared plus 9 squared, so 117. So when I take the square root of both sides, I find that x, the side of length of one side of my rhombus, is equal to the square root of 117. And now I have to go ahead and I have to express that in simplest radical form. The directions told me so. If they didn't, I would know automatically I had to do simplest radical form, because that's what we always do unless it's otherwise specified. So when I plunge a square root of 117 into my calculator, I find 117 is not a perfect square, but it does have a factor that is 9 will go in there 13 times. So the square root of 9 simplifies to 3. Square root of 13 I can't do, so he's just square root of 13. So the length of one side of this rhombus, 3 square roots of 13. The perimeter adds all sides. So I can either do 3 square roots of 13 plus 3 square roots of 13 plus 3 square roots of 13 plus 3 square roots of 13, or I can simply say the perimeter is equal to 4 times 3 square roots of 13. And 4 times 3 gives me 12 of those square roots of 13. So the perimeter of my rhombus, 12 square roots of 13. That's a beautiful question because it utilizes our knowledge of right triangles and radicals and simplifying radicals and perimeter. It really brings together a lot of nice ideas that we've talked about so far this year in the geometry course. Okay, number 2 says in rhombus ABCD, the diagonals intersect at point E. The measure of angle DAC is 18, and they want us to find the measure of one of the other angles. Like the first example, they didn't give us a picture, so I'm going to draw a nice picture. And I'm going to draw a nice big picture. I don't want any wimpy, wussy pictures here. A nice big picture. When I label my vertices, remember not to do any jumping or skipping. Go right around your quadrilateral. Because this question, again, is dealing with the diagonals, I'm going to go ahead and draw the diagonals in there. Because it's a rhombus, I know the diagonals are perpendicular. This point at which they intersect, they tell me to call point E. So measure of angle DAC is 18 degrees. So this little wedge in here is 18 degrees. Find the measure of angle ABC. So this is the one that we're looking to find right here. Well, like the first example, I'm going to start out by looking at a triangle. Because this quadrilateral is a rhombus, I know that all 4 of its sides are congruent to each other. So in my yellow triangle, I know that my triangle is isosceles. It has a pair of congruent sides, which means it also has to have a pair of congruent base angles. So this little angle, angle DCE, is also 18 degrees. Well, at this point now, I know that 2 out of the 3, or I know the measures of 2 out of the 3 angles in my triangle. I can find the measure of that third angle simply by subtracting from 180. So if I subtract out the 2 18-degree angles, I'm left with 144 degrees, which means my picture is kind of a cruddy picture, but it is what it is. So there's my 144-degree angle down in the bottom left-hand corner. Because every rhombus is a parallelogram, it has all the properties of a parallelogram, meaning the opposite angles are going to be congruent to one another. So this angle up here has to have the same measure as its opposite angle, making the measure of angle ABC also equal to 144 degrees. Again, this question, like the one before it, utilized or involved a lot of strategies that we've learned so far, and that you had to apply your properties of isosceles triangles in order to solve that question. All right, last one for this video. Number 3 says, if a quadrilateral is a parallelogram where 2 consecutive sides are congruent, is this going to be enough to prove that it's a rhombus? And explain your answer. Well, let's go ahead and take a quadrilateral that's a parallelogram. And it has 2 consecutive sides that are congruent. So there's my congruent consecutive sides. Well, because this fella is a parallelogram, I know that opposite sides are congruent. So I know the top side and the bottom side have to be congruent. I know that the right side and the left side have to be congruent. So all of a sudden, my 2 consecutive sides, by the time you added in their opposite sides, turn into 4 congruent sides, and therefore this figure is indeed going to be a rhombus. So the answer to that is yes. And as far as explaining your answer, a parallelogram has opposite sides that are congruent. So when you consider the sides opposite the consecutive sides, all 4 sides must be congruent, making the quadrilateral a rhombus. So that's something that's kind of interesting to think about, and is actually going to help us in our pursuit of writing some proofs that involve these special types of parallelograms. But that's another topic for another day. What I would like you to do is think about the key ideas and important understandings that I talked about on page 17. What's going to be an important takeaway that you're going to have to remember from this video? And then, as always, in your own words, summarize that up at the top of page 18, and then see if you can apply your newfound knowledge to solve the questions on page 18.